Sit perfectly still. Close your eyes. Count to 5. 1, 2, 3, 4, 5. Now, open them. In those 5 seconds, you traveled roughly 3,000 kilometers. Even sitting in a chair, you are on a planet spinning at 1,600 kilometers per hour. That planet is orbiting the Sun at over 100,000 kilometers per hour, and our entire solar system is circling the center of the Milky Way at more than 800,000 kilometers per hour. But there is a much larger motion at play. The Milky Way galaxy itself is hurtling through intergalactic space at a staggering 600 kilometers per second. We experience daily life as a period of absolute stillness, but our existence is actually playing out inside a violently fast, active cosmic flow. This extreme velocity is not random wandering. Our galaxy, along with thousands of others, is being aggressively dragged toward a specific destination. Astronomers call this unseen focal point the Great Attractor. Finding out what was pulling us proved difficult because of where it was located. From our vantage point on Earth, the Great Attractor lies directly behind the thick, opaque band of dust at the center of the Milky Way, a region astronomers call the zone of avoidance. Traditional optical telescopes rely on visible light, making them completely useless against this dense wall of cosmic dust. To figure out our exact place in the universe, scientists had to invent a way to look through the blind spot of our own galaxy. Since they couldn't photograph the Great Attractor directly, astronomers shifted their strategy. Instead of looking for visible starlight, they started tracking the invisible motion of the surrounding galaxies. They did this by measuring redshift. As a galaxy moves away from us, the light it emits stretches out into longer, redder wavelengths. By subtracting the background expansion of the universe, scientists isolated the peculiar velocities of thousands of individual galaxies, revealing invisible gravitational rivers pulling them. Massive radio telescopes like the Green Bank Observatory were essential for gathering these velocities, because radio waves slice right through the Milky Way's dust. Observing this kinematic data shifted astronomy away from taking pictures of static objects, turning it into a tool for mapping invisible forces. The resulting map revealed that the Great Attractor is not a single hyper-dense object. It is a vast, flat gravitational valley. This density map visualizes that discovery. The orange contour line marks the boundary of a massive supercluster. Inside this region, roughly 100,000 galaxies flow along cosmic filaments, pooling inward toward the Great Attractor, much like water descending a mountain. The dimensions of our home supercluster are staggering. It spans 500 million light-years across, containing the mass of 100 million billion suns. Researchers named the structure Laniakea, meaning immense heaven in Hawaiian. This honors Polynesian navigators who used the night sky to map the Pacific Ocean. Understanding the shape of Laniakea reframes our galactic identity. The Milky Way is an active participant in this structure, a single droplet flowing through a massive, interconnected river. Given that we are moving at 600 kilometers per second, it seems inevitable that the Milky Way will eventually crash into the center of the Great Attractor. But we will never actually reach it. That is because of dark energy, the omnipresent force that is currently accelerating the expansion of the universe itself. Dark energy creates a universal push that directly competes with the localized gravitational pull of the Great Attractor. The universe is an active, ongoing tug-of-war between the gravity trying to assemble Laniakea and the dark energy tearing the cosmos apart. In the short term, locally, the Great Attractor is currently winning this tug-of-war, actively dragging our local group of galaxies inward. But Laniakea is so large that its outer edges are not tightly bound by gravity. Eventually, dark energy will overwhelm the Great Attractor, stretching the space between galaxies faster than they can travel through it. Far in the future, the Great Attractor and the rest of Laniakea will be pushed so far away that they will simply fade beyond our observable reach. Human existence is occurring during a fleeting, dynamic window in cosmic time, a brief moment where we can still witness, map, and participate in the immense heaven before it drifts apart forever.